right. Hey guys, can you hear me?
We can hear you.
Cool. We'll wait a few minutes here. Cool. Okay, well, while we're waiting, I have, can you see my screen here with LinkedIn?
Yeah, we can see that.
Okay, cool. We're not going to be using this today, but if you ever need extra, like if you need to know how to do something, and you kind of want some credit for it with SolidWorks, LinkedIn Learning is free to all SAE students. And you can get like certifications within LinkedIn Learning. Then you can attach that to your profile. This is more, they have the basic stuff, and then they have like master SolidWorks, like a master class for some things. They have sheet metal, specific surfacing, drawings, weldments, all of the different aspects you could imagine. So this is a very useful resource, and they're all, it looks like they're all within the past 3 years. So they're still using fairly similar version of SolidWorks to our 2020 or 2019 version. And yeah, so it won't look super old. They're all pretty new. Yeah. Okay, so I think we can have JJ start sharing first, and we'll kind of like walk through how we use SolidWorks, and if you need a walkthrough of how GrabCAD works, he knows more about that than I do, and he can show you like the file system for that, and anything related to GrabCAD.
Wait, so do you want to start off with GrabCAD?
Yeah, I think that's a good starting point, just so that we know. Okay. I think we can work from file management to making a first part, and then from there getting more advanced into assemblies and sheet metal.
Okay.
And by the way, I have 2019 SolidWorks only because I need it for class. It's the same thing as 2020, basically. I think like the lines are a different color for certain what do you say, constraints, but it's the same thing.
Okay, can you enable screen share?
Yes. Okay, and you should have it now.
All right. So for actually, I don't primarily remember how to download GrabCAD. I'm pretty sure you just go on to Google and just literally download the program. But the way GrabCAD works, it's basically just like a cloud storage for all our like SolidWorks parts and assemblies and pretty much anything else. Primarily, we use it for parts and assemblies. But basically, there's two primary things that you see on this main screen when you open up GrabCAD, and that's your workbench and your local folder. So your local folder is exactly what it means. It's local to your computer. So if I click on this, I have all these parts because I never use my laptop. I don't have any of these. I haven't uploaded any of these parts, but I don't want to. But essentially, these are all the files pertaining to SR11 and SR12 or SR12. And these are all the files that are on my computer. So each one of these symbols means something else. So like this is a refresh. So what it'll do is it already knows that the part is in the file online. So what it'll do is it'll update that part. This plus sign, it just means that it's adding a part to the project folder. So if I go back to here, let's see. So if I open the project, you guys can't see it. 1 sec. So if I open the project, it just basically takes you to the online version of that program. And so this is everything that's been up to date. So it'll just keep updating. So Jason uploaded something October 4th, and it'll just keep like scrolling down. And this is so we can't like really lose anything, and then we can all kind of collaborate on one project. So that's essentially pretty much it. And the way you want to go about putting files into GrabCAD is before you even like start working on a project and even your local system, just download the whatever like updates that it's telling you. So like it's telling me that I have 117 updates that I haven't downloaded to my local folder. So I would click this and it would update my computer. And then you would want to go ahead and start working on your whatever part you're working on or assembly you're working on. And then, so like after you download the most updated project file, and let's say you finished editing your piece, you would basically upload your part and your assembly. So like if I open up so this is now on my C drive. If you go under your documents, you'll see like a folder that gets created for GrabCAD, and then our project is called SR12. And the way we've divided up each one of these systems is into folders, and within these systems, there's subsystems. So for powertrain, like let's say I was doing, like I wanted to add a bracket into intake. I would open up SolidWorks, make the part, and then I would save it into this folder. And then GrabCAD will recognize that a new folder or a new part has been added, and you'll just go back to GrabCAD. And this, let's say this was all concurrent, it would just say +1. And then you can add that part into the online, like the total project, not just your local project. And so everyone will have access to it. Also, when you do that, it gets a little bit tricky because when you, like, let's say I made that bracket and then there was also an assembly that it went into the total assembly, you could essentially just update the intake assembly and that'll update like within the powertrain stuff. So it might give you like 2 or 3 things to actually upload into here. And you can just basically either reload or upload them. So like by reload, I mean, it'll say update it, which will be like the assemblies. And since it's a new bracket, it'll have like this little plus sign. I'm pretty sure this is pretty confusing. I don't think I'm doing a good job of explaining it. But yeah, that's pretty much the gist of it.
Okay. And do we have in GrabCAD, do you know in the GrabCAD which folder has the templates for the actual part and drawing files? Like, you know, when you push new and you see like ANSI inch or something like that, do we have a template in GrabCAD, or are we using SolidWorks default files?
You're talking about drawings, right?
For parts too.
I'm not sure of that actually.
We don't, but we should be making them. We should also make ones for drawings.
Okay.
Because that's when we go to make drawings, that's going to make our life way easier.
Okay. You can make one after. Cool. So I think we can open SolidWorks now.
Okay. Let me close these.
Oh, yours is totally different. You're okay. You just made it to the dark view, huh?
Okay. So for SolidWorks 2020, if you use SolidWorks 2019, it's pretty much the same. I mean, I think the only thing they really changed were a couple things. You can look in like the update files, but I think for this, we're probably just going to go over some basic stuff like sketching, features, and the way you should go about in like designing parts. Before that, I just wanted to touch on like settings and stuff. So if you click on like this little gear up here, it's your settings tab. And this is like a way for you to customize SolidWorks to make like your life easier and to like optimize for your computer and like your key, like hotkeys and like mouse gestures and stuff. There's a bunch of documentation online about this, and really you just got to like mess around with like what you like. I think I'll probably like go through when we're building something to like show the difference between how mine's set up and like how a default setting would be. But yeah, essentially these settings will be different for, or they'll be default for everyone, but I would recommend going through and messing around or looking at each one of these and just seeing what you like, because it's really preference. Another thing, if you are new, like totally new to SolidWorks, you can actually click on, there's 2 ways to do this. You can click on this little like tree over here and this little home, and there's this little welcome to SolidWorks, and it'll open up the main like first thing you see whenever you open SolidWorks. But you can go to learn, and there's the stuff built into SolidWorks that'll like give you a general overview of like what's an extrude or what's a revolve and things like that. So even after this, I would highly recommend going through these, because ultimately the best way you get better at SolidWorks is just through practice. You just keep making parts and doing a bunch of small little things or messing around with large assemblies, and you'll get better at it. And the other thing is to actually go to My SolidWorks, like the website, and there's way more stuff than what they actually have built into SolidWorks than just the program. So you can like create an account, and I think like as an SJSU, or even with our license, licensing, you get access to a bunch of the educational stuff online, and that includes like simulation too. So it's not only just like making parts or assemblies. So look at that stuff, and they'll do a much more detailed job than what you'll see here. And then plus you'll see a lot more advanced stuff too. Anything else, Josiah, you want to add to that?
I think right now we're okay. I mean, actually, let's see here. You didn't talk about the file location yet, right?
The file location?
Yeah. So, let's see. Do I have the little pointer thing on Zoom? I'm missing here. No, I don't. Okay. Oh, okay. Oh, I'm controlling your screen. That's new. All right. Never actually done that before. Oh yeah, and if you're so when we do make those templates, okay, I should explain it this way. So when you click on new to make a part, this little box pops up, and sometimes there is another box that pops up here. Actually, let me just click on part and see if it gives me another option too. Oh, it doesn't. Okay. Oh, advanced. Oh, here it is. So see how there's two tabs here right now? There's template and there's tutorial. What we should do, or will do, is make our own templates here. And in these two tabs, there is a part, assembly, drawing. These are like standard. It's probably just inches in ANSI. And the same for tutorial. But you can make your own file location. And once you do, you just click on, let me do this, the settings here. And you have to point it to the file location. But we'll come back to this when we have those templates ready. This is where you would do it. See, right now it's pulling from the SolidWorks installation file location. And later I'll show you on my SolidWorks when we switch to my computer how it looks. And I guess to explain one step further on the units, you would want a separate file location for those folders because you can customize. So I say like our team only wanted to do metric, then by default, when you went to go open a new part on file new, then it would always go to metric or always inches or whatever units we wanted. You can change these here. See, there's a different standard MKS, CGS. I think we use. I think powertrain is all metric. I don't know if the entire team's metric, but yeah, we have these different options, and then you can even specify how accurate you want to be with your part, or you can do that on drawings too. You can change them. So we'll explore that further, and I'll give Josue back the control here. How do I do that? All right, JJ, can you take back control, or how does that work?
I think I got it. Yeah. Okay. Yeah, so I guess I'll just jump into, so what I was planning to do was just work through a CSWA problem, because it probably takes like 20 minutes, 30 minutes to make like one of those parts, and then it goes through like all the features, or the big features at least. So I'll just do that, I guess.
Okay, and then after, go ahead.
What is a CSWA?
It's a SolidWorks, like certified SolidWorks. So you become a certified SolidWorks associate, I think. It's basically a certified, you get a certification for like basically telling your work or whoever or just for yourself that you are like competent at using SolidWorks. It's a certificate.
Gotcha. Thanks.
Yeah, and if you take ME 165, you actually take your CSWA for, I always forget what it's called. I think it's design and then like simulation. But you get 2 certificates basically given if you pass both of them with like a 70 or higher.
Cool. Thanks.
Close this, then I'm gonna move this to this side. So this is a practice exam for a CSWA. And I guess we can just go through and build this. Okay, so we'll open up a new part since we're gonna make a part. Is it super laggy, like when I move really quick? Like if you can't see anything now.
It's pretty responsive, I think.
Okay. So as Josiah said, like the first thing or one of the things that we want to take into consideration is like what units we're going to be using for the part, because you want to be consistent with all your units. So for this part, it specifies that you want to use millimeters, grams, and seconds. So you can change that by either going the way that Josiah showed up in the tool settings, or you can just click down here and then you can click MMGS. This also specifies that you want to have 2 decimal places. It's the same button, and you can edit document settings. And it's pretty much already been done. You can change this back to 2. And those are the general settings that you initially always want to kind of just set and forget about, because you don't want to change in between like dimensioning and stuff. The other thing, you can do this after. I primarily do it after, but it's better practice to do it in the beginning, is to edit the material. So this calls for AISI 1020 steel. So we'll click on, or let me go back. So we'll click on material, right click, and then you can edit materials. And then you can either type it in if it's not like completely visible. As you can see, there's like a bunch of different built-ins. I don't actually know how to go in and like add your own yet. But for the most part, usually this stuff is, they're pretty specific and they have quite a wide variety of materials here. So
yeah, and if you don't know a specific one, if you scroll down a little bit, I think there is like a generic like plain carbon steel option. That way you know that you want the part to be steel at the least. Oh, yeah, especially if you're like an intern designing a part, you don't know like all the different types or what they do. You can use this option, or just type it in the drawing phase.
Sweet. Okay, so we'll click that and then we'll hit apply. So for my settings, I don't know if default they like do real view graphics. I always turn that stuff off because it's annoying to me. And then the other thing I always do is make my background white. I just like it. And then it's also good practice for when you want to like snip stuff. You don't have like that weird shadowing that happens. So the way you actually go in and change your background settings for this like permanently is to go to the settings icon, and then you go to, not this one, colors. And then you can click plain and viewport background color above, and you would click this viewport background and then edit your color. And I choose white, and it's always that. So whenever I just want to add it into slides or something, you don't have like that whack shadowing in the background. If you don't know what I'm talking about, oh, it's set. maybe the 3-point fade. So you get like this gradient looking thing, which I don't like. So yeah, that's all set. So I don't think I don't use it that often, but for the CSWA, you want you to like go in and set in like parameters for dimensions. The way to do that, you go to, why is this thing covering it? Tools, and then you go to equations, and you can add in a bunch of global variables here. So this calls for A to be 81. Whoops. And then B, let me change that. Oh, I'll do it after. It is 57. It's picky about the quotations. You hit enter, and you can add C at the end. And I'm going to change this to capital real quick. Okay, so these are set. I think that's pretty much it for settings. So that's just your initial setup. To actually start making this stuff, so the way you go about making parts is you start off with a 2D sketch and you build that sketch into a feature. So a good way to go about building stuff is to visualize like the easiest way to make this piece right here. So it's kind of given to you down here. They want you to use this front view, like this surface right here, to like make your 2D sketch, and then build based off that. You don't have any of the dimensions up here, and it'd be kind of difficult to do it as well. So yeah, we'll start off by making a 2D sketch on the front plane. And the way you do that is you basically, also forgot to mention, there's no like right way to do or make a part. There's a lot of different methods to go about doing it. And it's going to be like different based on your approach. So you can end up at the same, like, you can end up with the same dimensions and same weight and everything, mass for your part, but you might go a different way about making it. There's probably more efficient ways and there's less efficient ways, but ideally you get better, like I said before, you get better by practicing. So the reason why I chose the front plane is because down here they kind of give you a 3-view drawing, and this is your front plane, this is your top view, and this is your side view. So I'm gonna put this on the front plane just so when we actually go over and make a drawing of this, it'll already be set up in a 3-view. So you can click on this, and then this little sketch guy will pop up. So now you're in sketch mode. This automatically switched over to sketch. And the one thing you want to think about when you actually start making the part is defining where you want to put your origin. You can put it in a bunch of different places. It really comes down to how much it's going to help you out when you actually start like dimensioning off this stuff, like putting out this length or putting out this length. So I'm going to choose my origin to be in this like bottom left corner, just because all these leads are kind of coming off this way. But you could put it right here. You would have to do probably a little bit of like math to actually get all these lengths out. So yeah, I'm going to choose this bottom right corner. So these are pretty straightforward. There's a line tool, there's a line sketch, a circular sketch, corner rectangles, center point arc. These are slots right here. This is a polygon, sketch fillet. You can go through and mess around with these after, and these all break down into a bunch of different other kind of sketches too. Oops. So what I'm gonna do is basically make a giant square around this entire part, and then I'm just gonna like cut away at these where these lines are. So I'm gonna make like my border, I guess. So I tried this earlier, but it didn't work. But so I hit enter twice. I have a setting where I put in dimensions right away. I'll do it later on, but it didn't work when I put in the variables for some reason. So I want to have this be a construction. I don't want to actually like use this as like a sketch, like a defining line. So you can click for construction and it'll change like the entire sketch to a construction sketch. And these are just used as references. So I'll be able to, you know, dimension all these small points based on this box. So I'm going to change these to your variables. So you can hit equals, and then you can go global variables, and this one's 57. And this one is A. Okay. So that little sigma sign will pop up next to it when it's a function. Okay, so that's pretty much set. Now I basically just want to do like a rough outline of this thing, and you can pick any point to start from. I'm going to start from this point just because it's on this axis and it's on this line already. So I'm going to use a line tool to like rough out the sketch. And what I'm cautious about when I'm doing this is I don't want to add too many relations between the points. So like right now, there's that coincident relationship that's popping up, and it's basically just saying it's going to attach to this line, which is what I want. And then I want this one to also be coincident, but I don't want it to be at 45 degrees, even though it says 45 degrees. I'll add that in after. So just going to do this, go up this way. And then for this curve, you can either exit out, like hit escape. But if you like slide off of it, and then hover back on it, it turns into like a arc. Can't get it to go the other way. Rip. Oh, it's not gonna actually go that way. Okay, we'll come back to this one. So I will just add in a line right here for now, and then I can add it in after. That one is not connected to that. I don't want it to be horizontal to the midpoint, so I'm just gonna like scooch down a little bit. And then this one, I'll make it horizontal. I want these points to be the same based on the drawing, but I don't want it to be down there. So what I'll do is click on that, I'll delete the relationship, and then I can like freely drag this up. And then I'm basically just gonna do the same thing. I think it'll work better if I do it here. That arc. So it comes off. So I'm not clicking on it or anything. It just kind of changes over to that. And then you can do it again to another arc, and it'll be tangent to that arc. And I want it to connect to that. Bring this over, and then that can go there, and that can go there. Okay, so now it's a closed surface, so it changed shades. From here, you're basically just adding in all those dimensions on the left side. I'm also missing a circle in the middle. So I'm just going to add it. I don't want it to be constrained by those points. Okay, so I added that circle. So for my mouse gestures, I went and have like an 8 wheel. So if I hold down my right button, I have like all those things. And that's just like for, I don't always use them, but whenever I remember to, you can just like quickly move over, and like if I want a dimension, I just move up and I can dimension this pretty quickly. So that'll be 14. But the way you set those is you go, nope, not here. To tools, and you can go to customize. And you go to mouse gestures, and then you can select how many gestures you want, and then you can basically just drag and drop based on like what features you want. Same thing for keyboard, you can set like hotkeys and stuff in your customize tab. Yeah, so this is going to be a bit tedious, but basically I'm just setting in a bunch of this stuff. I didn't select that. So that'll be 45 degrees. To make like, so essentially these two corners are like the same. I'm not going to do it 2 times. I'm just going to do one side and then make these both parallel with the relationship. So you can click on one of them and then click on the other, and then, whoops. And then you have a bunch of these relationships. So you click on one, and then you can click control on the other, control click on the other, and then it'll pop up all the relationships. And then I want them to be equal, and it'll automatically change it. The other way you can do that is also by clicking on this, and you can add a relation to anything. You just have to click on the points manually then. Okay. Let's see. I actually did this part earlier. I think this is like pretty straightforward. You're basically just going in and changing. You're adding in all these dimensions, and what you essentially want to happen is these lines should no longer be blue. So it says underdefined down here. This should say fully defined. You always want to have your sketches fully defined, because when you start working with like large assemblies, it's just bad practice to not have a fully defined sketch as your base. So all these lines will turn black, like, let's see, where did I put that? This one. So it'll eventually, you can go through and like add in all these dimensions, and it'll be completely black like this, and it says fully defined on the bottom. So once you're at this stage, you want to actually make it like a 3-dimensional piece. So you would exit sketch, and you would boss extrude, which I already did. So let's see. So if I delete this, is it going to delete my sketch too?
No, it'll keep your sketch, but it'll delete all of the sub features.
That's fine.
But you can also just highlight the sketch and make a new extrude based on that sketch. So just click sketch 2, go to features and extrude again.
Wait, what?
Just click sketch 2, click features,
Oh, and extrude it again.
and just re-extrude it the other direction or something, just to show.
Okay. Yeah, so so I will do that. So click my sketch, go to extrude, and then it's going past, so I'll just flip the direction. And you can set like how far out you want it to go. With this, there's a couple other settings that you can choose. So you can have a mid-plane sketch where it'll basically split it. So put the plane in the middle and then split it like if this was 80, this would be 40 this way and then 40 this way with your midplane in the middle. And that's a good thing to do when you have symmetrical parts. This isn't necessarily symmetrical, but if you have like a U shape or something, you would want to use a midplane sketch because you want to keep your origin at the middle. Yeah, I think that's pretty much it. So for these, I'm basically building this next part of the model. So we built like this fully solid thing. I already had added the hole in, but we built this fully solid thing in the beginning, and then they want us to build this, and essentially what you're doing is just cutting away pieces of this model. So, whoops. So your final piece will look like this, and you can kind of see it get built through like so. It's not going to look right now, but the way I went about it was I cut away this piece first. So I made a sketch here on this surface. You can look at it. The way I did that was I only added in this one line, and then the rest of these, you can do convert entities, and what that'll do is you can click on like any of these like projected lines, and it'll put it onto the sketch plane that you're working on. So I can, highlight all these or whichever ones I want, and then hit, OK, and it'll put it on that front plane, which is my sketch plane. So I did that. Another quick and dirty way you can do it is to actually just make a giant rectangle and then just extrude out or extrude cut however far you want to go. But then again, you're not going to be like defining anything unless you set, your like square rectangle dimensions. So I did it this way just because it's good practice. So if like this model changes, so if I change this one, like the shape up here or something, it'll also change within this sketch. So yeah, I cut away that piece, and then I created a plane to get like this groove in here. It's not in the middle, as you can see. So like this length is 44. The C length is 44. This is 12. This is 24. This is 8. So this U groove isn't in the middle. So I put this plane in here by doing like subtraction of like this length plus this like mid length. So it's 12 plus 12. So this plane is 24 millimeters from this side over here. And that's the middle of like this piece. So I added this plane in, so now I have a sketch plane. And what I essentially did was I sketched a arc on here. And then I did the same thing as I did before. I just added in the offset entities. And then I just did a mid-plane cut extrude because I want 12 this way and 12 this way. If I move my plane like to the outer edge of this, I would want to do a blind cut extrude this way. There's multiple ways to do it. I just did it this way. And then that was pretty much it. I had already added the hole in my initial sketch, but if the hole wasn't there, you could sketch on this front plane and just do a through hole all the way to this surface. But essentially, once your part's created, oh yeah, I also cut away this piece. Same concept as before. You're basically just selecting the plane and then cutting, or selecting your offset, or not your converted entities, and then cutting away at it. And so once that's done, you can create a drawing from this relatively easily. And that's because everything is fully defined. So this part's already saved. We can make a drawing from the part. And let's see. So you can do a standard 3 view of this. And so it'll plop them up. So this is your front view, your top view, and this is your side view. And when you go to annotation, so this is like to individually smart dimension pieces in here. If you go to model items, you can just import all your dimensions, and it might do like some over dimensioning, but it's much easier to go back and delete this stuff. And the reason why these are in inches is because mine is set to a different standard. So I'm going to switch it back and it'll automatically convert everything. But essentially, that's pretty much it. Anything you want to add, Josiah? I feel like I was just rambling on.
No worries. See, as you're finishing that drawing, I will get ready here, and then I have some other things to show. We'll do sheet metal and a different approach to making parts, maybe more for intern level. Yours was really useful for designing a specific part, and thank you for showing that. Okay, let's see here.
You want me to stop share?
Yes. 1 second. Okay. Check the chat here. Oh. Oh, thank you for coming. Okay, so now we'll continue. So similar to JJ, let me show you before I go into sheet metal. The project that I did for my class, Tech 140, I think that's the introduction to green part design. They actually had us go through this book, but for 2019, and the first 4 chapters, and they basically taught you everything from how to make the templates, how to do the part, how to modify it in the assembly. So I will show you the result of that and kind of what I did. And then we'll go to sheet metal. All right, we'll be over in the chat. What are you saying? Oh, okay. So first of all, this is how we had the file set up. We had the templates folder where you keep those templates I was talking about in the beginning for the specific units. And then we have a project folder. These are all where all the parts are. And you can see here, just from the file image, we made an assembly with 3 main parts, a guide, plate, and rod. And through this process in the book, they showed us the different ways that we can make that part, not only in one sketch, but in multiple sketches, and even in the assembly. So I'll show you some of that. And it's if you have purchased parts, it's a good thing to keep those separate. So like if you download screws from McMaster or something, then don't save them in the same folder. So let's see. I won't spend too long on this, but I will go through it so I can show you some of the things that they taught me. Sometimes SolidWorks takes a while. All right, so my setup here is more of a stock SolidWorks. So like, the gray background, everything here is white. This is how it comes downloaded. So this might be a little more familiar to you guys. So this is the part they had us made. And let's see, I think I can, okay. I'll go through the basic steps of how this part is made. So you start with nothing. By the way, you can drag this bar to roll back the part to different phases in it. We started by making the sketch like we saw Josiah do. This is like the main sketch where everything is, the profile is made. And then we extruded it from the mid plane. So the front reference plane here is in the middle of the part. That way it would be easier to mirror features later on if you need to. And you can see when you make the part, all of these things there are what do you call it? Designed about the origin. The next step here, we used a slot cut. So this here, we use a slot. It's it's just a straight slot. And for slots, there are you sign the length of the middle here, then you have the radius, and then you reference. For this one, we referenced from the middle point, the origin here, to the center of the slot. That's how we did that. Then we mirrored that slot to the other side. So this is a good thing about having planes lined up. If you didn't have this part designed about the origin, then you would have to add planes to mirror that part over. And to do that, you have the reference geometry. I'm showing you more of how I kind of make parts that work. So I try to follow most of the rules, but if you're a new intern and you don't know everything, that's totally fine, because the parts that you design may not need to go on the car, so they don't need to be completely fully defined, but always strive to have a fully defined part. The reference geometry here, you have different options you can use from plane, axis, coordinate system, point, and all that. So you have the plane and you just select two parallel planes that would make a plane in the middle. So I'll just do it here real quick so you can see. And you can also just do one plane if you want and dimension how far away from this face of the part you want it to be. In this case, you click on 2 of them and it centers it. By default, you can still change it if you want, but and then from there you could select the slot and mirror using the linear pattern tool. And here's a mirror. Okay, but we don't need that plane, so I'm going to delete it. After this step, we made a guide hole. I think we used, this one is just a sketch. We did not use hole wizard for this. So this is very simple. You on sketch, make a sketch on this plane here, draw the circle, give it dimensions and a location based on a certain point on the part. That way it's fully defined. The next one here, we actually use a feature called a hole wizard. So this one, I can show you how to use this from the beginning. So let me actually, you know what? Okay, hole wizard can be found, where are you at? Wizard. Oh, yeah. There it is. Here's hole wizard. Thank you, Russ. You click on hole wizard. So you click on that, but for this case, I'll just open it since it'll take you here if you click on hole wizard. From here, you can select the type of hole that you want. There's different types. If you scroll over them, you can see there's a counter bore, countersink, hole, just a normal hole. Not sure what legacy hole is. I haven't used that one before. There's a tapered hole, so that kind of angles down into as you get into the depth of the hole. A straight tap. This is a tapped hole. The counter bore slot. You can see the different options here. The hole that I chose here, I believe, is a straight tap. So this hole is a tapped hole. You can define which standard you want to use. Since this is a metric part, we use the ANSI metric. There are 3 different types of taps for this one. There is a bottoming tapped hole, a straight pipe tapped hole, and just a normal tapped hole. So the bottoming tapped hole, I believe, so when you think about taps, like physical tap to make the threads in this part, there are 3 or 4 different types of ways you can make the threads on a part. And the one that this is a bottoming tapped hole. This thread goes further down the hole than some of these other options here. I wish I had a reference here. Let me. We'll just do this. Okay, this might help. Okay, so you see here, the bottom tap has more threads. A plug tap is a little bit tapered at the end here, so it would when you put in the screw after you do this, it wouldn't go in all the way. Bottom tap will go a little further, and a tapered tap goes even less. So this is just one example, but think about the tool that you're going to be using to make or cut the features when you design parts. And this is one example just for tapping. We'll go into more in a little bit here. Then you continue going on to define which screw size. Solidworks has all the different sizes in here, thankfully, or most of them at least. Our part's metric, so I chose the M3 screw. So in metric, the number after the M is the diameter, and the number after is the pitch, the thread pitch. So this is M3 by 0.5. Cool. All right. The next is the end condition. So this is basically how the hole is. If you select blind, then you could define how deep you want the hole to be. In this case, it's 7.5 millimeters. If you didn't care, you can make it go all the way through the part, and through all literally means like not only this feature going through this feature, but also the bottom. So just you'll see that when you make your part. Normally, you want to do a blind hole unless you're doing sheet metal, then it doesn't really matter. And you can also define, so this is just for the hole. For the thread, you can define how far down you want the thread to go. You would do this in, so say you have one of those taps that doesn't go all the way down. You want the hole to be deeper than the amount of thread that you need. So say you want the screw, you have a 1/2 inch screw and you want the screw to go all the way down 1/2 inch. You want the hole to go deeper than a 1/2 inch, maybe like 6 to 5 or something like that. So this is where you would define that. Okay, and I believe, and then positions is where you would make the sketch here. It'll see this. See how it's dragging here. I can just click anywhere, and then you'll be able to put the dimensions. And then you have your hole. So notice there's no thread on here. This because with this feature, they don't put the threads in here, so that way when you make the manufacturing drawing, or if you send the step file to a company, they don't have to like go in and remove the actual thread you cut, and it's just for reference basically. So if you actually want to see the threads, then you'd actually have to go and extrude stuff like that. Right. And you can also do combination holes, I think. You can add a countersink on here if you want. And if you don't want to go through the whole hole wizard process, you can do a chamfer, but it's good to go the official way with hole wizard or any tapped hole. And then, so you don't have to make all of them. You can just make one hole. And like I mentioned before with the mirror, you can also pattern features. So in this case, I patterned a feature here, also using the linear pattern option on top here. You can see you can linear pattern, you can do circular pattern if you have an axis, and all these other options. So I'll open this so you can see. You have to, for patterns, you have to, linear pattern, you have to select the direction. If you only have one row of parts, then you only need to select one direction. But if you have two directions like I do, going up and to the right, you have to select both edges. So here I selected this edge and this edge. And notice you can change the direction either here at the arrow, see now it's going down instead of up, or you can change it over here on the left. So there's direction, and then the spacing between these holes. Now it's 10 millimeters. I can change it to 12, and it'll increase. You can define that as you need. And here you can add more features if you want, but in this case we only want the hole. Click OK. And lastly, we did some fillets. So one reason you would want to do a fillet, and maybe not particularly for this part, but if I were to make this at work, we don't have a lot of 5-axis machines. This part is probably not the best example, but in general, you don't want inside square corners. So say if the circle here was a square instead, the only process you can use to make that square would probably be an EDM, and that process takes a while to cut. And if that's a little bit harder. to get, you can also, there is such thing as like a square cutting hole for a mill, but there is limited options for square holes. So instead of doing a square hole, an end mill that cuts the material is round. So you want a radius on 90-degree corners that are inside. If it's outside, like over here, that's fine because the mill just comes all the way over here and then up. Over here, you wouldn't be able to get that sharp angle. So having that radius here would be good for manufacturing. Okay, so this is just this one part. And to show you, this is an assembly, but assembly is not only for assembling parts. You can actually right click and edit the part in the assembly. See, now I highlighted this part in blue. You expand it, and these are all of those things I was showing you earlier. This part is a cylinder part, so it'll probably be made on a CNC lathe. At school, since we don't have CNC lathe, it would be made on a lathe and then a mill for this part. The flat part here. This is basically the same. We'll go through really quick. So you start off with your raw stock, just a rod of material. Basic, usually all a circle, and then extrude, extrude that. Same with the front hole. So this, I used a hole wizard as well for this piece. This is just a hole, not a tapped hole. So another example for hole wizard. See, we selected just the hole option. And we selected a drill size. So here you can select drill size, or if you're gonna use a dowel or a helicoil, you can do different options. And we selected the depth 10 millimeters and the position. Okay, then we chamfered this edge here. Chamfer tool is like under fillet. Some of these parts are hidden in the drop down menus. So fillet makes it round, like you saw in the last part, and then chamfer cuts it at an angle so that it's flat and not at a radius. Chamfer, let's open chamfer, because in chamfer you can do the standard. I think the standard is 45 degrees. Let me, what did I do? Yeah, the standard here is 45 degrees, but you can we call it move. You can select different types of chamfers. So here, can't really zoom in that far, but it gives this diameter here is one dimension, and then the angle is the other. But you can also, if you don't know the angle you want, or you have different measurements to go off of, you can actually you can change this angle basically to, you can use angle and one side, or you can define both sides to get that chamfer. Okay. Next, we did a keyway cut. So to make this one, let's open Sketch. So making flat patterns, how do you say, flat features on a round part can be tricky sometimes, but luckily for this one, we still have some flat planes to reference off of. So you make your new sketch and then you reference a flat plane. And although it's going to be round and this part will be cut away, when you make the part, you still want to kind of have it lined up. So you click on the front or whichever plane or orientation. That way, when you make the drawing, it's not at some weird angle for the manufacturer to get confused. So this line is vertical compared rather than like just drawing a random line anywhere. Try to keep it consistent design about the origin. Okay, and then we made that sketch, do a circle, make a line, and then extruded that back. And yep, that's that part. In the assembly here, assembling parts is very easy, especially if you're doing small assemblies. The car can be tricky because you have a lot of people adding parts at different times, and it breaks. But to add components, you make the part, you save it, and you go to insert component, and here I have guide, so I can add another one of these if I wanted to, and you can keep doing that. Let me get rid of this thing. For screws, for example, if you are designing a part and it has, and you want to put all the screws in CAD, and you don't want to keep clicking insert, click on it, put it in here, and then this disappears. This little pin right here will keep it so that you can keep adding parts until you have as many as you need here. And then you click the green arrow or escape, and it'll stop inserting parts. Okay. And let's see here, load pattern. Okay, so similar to doing a linear pattern for a part, you can also linear pattern parts. I don't know how well this would work with the car, but for small things like this, if you know what, let's actually mate the screws. This one, delete, and all right. Really quickly, we'll go over mating, but this is just for very quick reference. I believe it was projects, vendor components. No, it's fine. We'll just pick this screw. All right, we'll just do one screw, and then the rest of it is pretty self-explanatory. So insert one component. Here is a flying bolt. Ralph might have a different opinion on how to do this, or a better way to do it actually, but I like to select the radius or a circle if there is one, and then either a diameter here if there is a flat surface to mate to. Sometimes the threads, if you download the part from master, don't properly mate. So basically make sure it's just vertical. And then click OK. This mates it to the corner here. If you wanted to put it in the middle, you'd have to select it for a couple other points. And then to mate it down, you select the top plane and the bottom of the flange. And that's mating. So mating is pretty simple. To get things to move, you have to be selective about which mates you want. See how this doesn't rotate? You can do parallel mates, like it doesn't have to be completely solid. Like see this nut still moves. So if you want it to be parallel to this face, you select the face, and then see it automatically switches to parallel. It won't let you do coincident because it's already mated somewhere else. It'll give you an error. Let me see if I try clicking OK. Yeah, it will give you this error and it'll ask you if you want to break a previous mate, but I don't want to do that. I just want it to be parallel. So you click OK. There's a lot of different ways you can mate parts, but I'm just showing you the very basic ones. The different types of mates are coincident, parallel, perpendicular, tangent, concentric. This means, like, you know, if you have the bolt here and the radius, you can see they're concentric. All right. So, and then the linear pattern, I'll show you really quick before we go to the next topic. You click on the direction you want this to go. So we'll just pick the bottom edge, change the direction of the pattern, and then click in the space, the white space of components to pattern, select the bolt, and select the quantity you want. So I only want 2. And now you can put in, I'm not sure if I can click on this. No, I can't. Okay. Right. Delete. I believe this is 60 millimeters away. Click OK. And that's how you use the linear pattern. Okay, moving on. Really quickly, I'll show you the drawing for this. Well, I won't actually make the drawing since I already have it made. Wait. Projects. All right, just as a disclaimer, this is all textbook, but these are good dimensions to have. When you're making a drawing for a manufacturer, you want to give them just enough information to make the part, and maybe a little more useful information, like some notes. Maybe you don't really care about how deep this hole is or what tap they use. You know, you can specify that in a note. But definitely overall dimensions, so the 150, so that way they know which, and this 30 here, so they know what size of aluminum to cut at the salt operation. And then from there, the programmers can use this drawing and the CAD to make the part, or make the program for the part. Consider that when the part is sent to a manufacturer, for example, if you don't tell them that the drawing is different from the part, just for us specifically, not in like production part environment, but for sponsored parts, try to make your CAD exactly the same as a drawing, except for the threads, that way it is easy for the programmer to program, and then they look at the drawing and then they can just program they select the tool for the threads and make minimal adjustments. All right, so we have 3 views here. We have a projected view. This is a projected view right here. It is based on this, what do you call it, plane here. It basically turns at 90 so that we can see. We have a detailed view. So you select a point, you expand it out, and then now you can see basically a close-up of this part. This part doesn't have any dimensions on it, but here's where you could specify like how deep this hole is, the diameter, thread type. Okay, let's see here. What else we have? Okay, we will leave this here for now and go to, I'll cover sheet metal quickly in the last 10 minutes that we have. And then if we have one more time after, if you guys want to stay, we can cover more. But sheet metal is one more thing I want to cover since we do have a good amount of it on the car. Okay, here I just drew this very basic rectangle with 3 holes. The holes don't really matter. What is important is that we have this one, one plane. I extruded it to 47 thickness, so 47 thousandths of an inch is a fairly standard, sorry, this is 050, fairly standard thickness for sheet metal. So when you're designing sheet metal, consider the different thicknesses that are available, either if we're going to buy it ourselves from McMaster or from a company like Mass Precision. We have specific thicknesses, and if your thickness is not one of them, then it might be more expensive because we need to order that on a special order. So you have the part, you extruded it. To make it sheet metal, you go to Insert, Sheet Metal, and then Convert to Sheet Metal. This is the first step after making the initial extrude. I'll make this bigger here. Here, it usually has some default standards. Beware that sometimes it won't be the same thickness. The thickness that's put in here, this T1, determines the actual thickness of the part from this step forward. So if you made the part 050 in the previous extrude, but you say you make it like 074, then it'll actually be way thicker from here on out. So make sure to match the thickness of the extrude to the thickness of the sheet metal here. So here it's 050, type it in, and now it's the correct thickness. Okay, there is some other options in here. If you designed your part in a different way, I like to start from one base and then use the sheet metal features to make the flanges and then sketch on the flanges. But if you drew a sketch similar to JJ's in the beginning, where you would draw each flange and then convert it to sheet metal, then you might run into some issues later. So now you have your flange. Let me see if I can get the sheet metal tools to stay here. Sheet metal. Okay, yeah. So on the left here, if you click on View, Toolbars, Sheet Metal, it will keep this tab, this section here, just so it's easier to get to. That way you don't have to go to Insert Sheet Metal every time. To add a flange, click on Edge Flange. There's different types of sheet metal options here. Actually, before I click on that, you have Edge Flange. I'll just actually draw some so you can see. Oh, that's way too big. Okay. Let me just make it smaller first. Oh my goodness. Wait 1 second. This is too big. Why is this huge? Oh, you know what? I think I know why. Let me make my sketch bigger. Yeah, that's why. Right. Sorry, I put like 6 millimeters instead of 6 inches. So good reason. Another thing to be cautious about when selecting units for your part. Okay, now it's in inches, not millimeters. And let me make, I'll just delete the whole. Actually, Okay. Okay, I will explain the reason why I'm drawing these three holes in a second.
Does Solidworks have like a scale feature where you could just scale it up?
Not that I know of. Actually, there is a offset entities, but it won't. It'll only offset one thing. Like it won't select everything at once. Let me see. I might be able to.
There is a scale feature.
Okay, I have never used it. Okay, so exit that sketch. Now we have our flange we can make. So this is edge flange. Select that. This is an edge flange. Basically just a bent piece of metal. When you're in here, you can do a few different things. First and foremost is the angle that you want it bent at. 90 degrees is usually what I work with at work, but you know, you can do different angles if you want. Only, you know, that's up to you. We'll stick with 90 degrees for now because it's a little simpler to explain. You can edit the flange length. So I'll make this 1 inch. Okay, now this part is where it becomes useful. Actually, I'll make this smaller so you can see better. Okay, these three options below, I put in ½ inch here, or it says 12.7 millimeters. This measurement measures from the top of this material to the edge. If you want the straight part of the flange to be ½ inch, then you select this, and it only measures like here. And this would measure if this part were at an angle tangent to the top of the part. So let me actually do 110. Oh, that doesn't work. Okay, we'll just take 190. All right, and then see how the flange is currently lined up with the top of, oh, sorry. What did I do? Okay, redraw that. All right, minor technical difficulty. Okay, like I was saying, see how the flange here is lined up currently with our previous extrude. That can be changed here, so you can have it lined up with the outside of the material thickness instead of the inside. It's very subtle movements here because this is a thin material. You can also extend it if you want to start the bend after the extruded material that we made. If you need this entire length to be flat, you can use different options here for different needs. I usually try to, well, it depends on what you're designing, I guess, but let's just use this one for now. Now, the outside of this piece of metal will be the same diameter that we made our initial sketch, 101.6 millimeters. All right. You see, this is now this bend radius, this is the bend radius. This is way too big. You wouldn't really make this unless you have a roller. There's no, or a really big die. So to change that, you go back into, you edit back into the flange. And so this is the bend angle. The bend radius is here. You uncheck, use default. Some common ones at work, you can do anything as small as 1/32, maybe even a little sharper. It's really sharp, but thin materials can do that. So you can actually type it in, or if you know the decimal, that's fine too. 1/32. Why did it change? Oh, there it is. See, now it's really small. And if you do a bend radius this small on a thick material, it might not work. It might even actually crack the material. But 1/32 is the smallest you could go for manufacturing. I would a more common one is like 1/8 or 1/16. So we'll just do 1/8 to show you.
You do 1/8 of an inch, right?
No,
Not 1/8 of a millimeter.
Yeah, well, I think that's fine. Pretty fine. I should have changed this to inches. That's fine. Okay, there we go. Anyways, let's just stick with millimeters because it shows my point a little better. Okay, so those are two things: bend angle, bend radius. The K factor here is something that we don't really use at school, just because we don't really know what it is for the manual. I don't even want to call it a brake press that we have in the shop. It's just I don't even know what it's called. I call it a brake press. We'll just say that. But
It's a box and pan brake.
Box and pan brake. Okay. When you bend a material, it expands a little bit, and that is dependent on the thickness of the material and the bend radius and bend angle, and that gives you a K factor. At mass precision, the K factor is actually a bend deduction because we air bend. What that means is basically when you bend the part, the die, it's just kind of the part is floating in the air. The K factor here, the normal K factor, I think, is meant for coining. This is a little less important, but if you were to have parts made at my work, I would give you this dimension before you send parts to me for forming, and then I would put it in here. And this could, the difference between having this set as default and actually putting it in here could be up to like 20 thousandths or more, depending on the thickness of the material. So I don't have the formula for that because we use a special calculator at work, but that's how you would put in the K factor. Okay. Now, let's add on to this really quickly here. You know what? Let's do an arc. Oh, let's do a 3-point arc. I'm just going to make a simple bracket so I can show you two different options for making the bracket. What happened here? Okay. So then make sure it's the correct direction. Okay, and then we'll just add a hole. sketch it, sketch, extrude cut, blind or through all. In this case, I'll just do through all. And then I'm gonna mirror this. All right. So I want to mirror all of this, so I select all of that and then go to linear pattern, mirror. Oh shit. Click on the plane, and then it mirrors. Okay. What I've seen us do is for actually bending these in the shop is when this piece comes in, I think we are like coining it. So there is a rectangle that goes on top that is the inner diameter, and then there's a slot cut out with the outer diameter, and then somehow there's supposed to be pins that line up. Theoretically that works, but I think there's a better way to do that. So instead of using a coining method, you can use either the air bend or that bending tool that we have in the shop by adding a piece of flat material to the outside of this that's temporary and breaks away. Well, what I mean by that is, let's draw one really quickly. I'll do a block. Actually, it doesn't even have to touch that. Wait a minute. Ignore my quick drawing. It doesn't have to be anything fancy. If you want, you could make it be the same dimension as the width of this part from this angle. But just for example, I'll do it this way. I'm not going to dimension it. All right, so this is material here that touches doesn't have to be very big. It can it could be as thick or thinner. Actually, yeah, much thinner than the material if it's a thick material. I would say like a 1/32 or 1/16, just a point basically touching so that you can break this piece away after. Let me see if I can extrude this, if it worked properly. Yep. Okay. Close enough. Okay, so yeah, instead of putting this part under a arbor press and you having a slot and a middle piece to bend the part, what you would do is you put this part flat. Let me actually unfold it. So to unfold sheet metal, there is a button called unfold and also fold. Unfold, click on one flange. So collect all bends, unfold, bam, that's your flat part. So you bring this flat part up to the brake press or machine that we have in the shop. You set up a backstop, something that this edge here rests on. You measure from that backstop to where you want the bend to be, And then you don't need a coin, they call it bending die anymore. You have this reference, and then the point of this is where it bends. And this is more common in my type of work. The machines that we have, this piece can doesn't have to be parallel to the edge flange, because we have more advanced machines where the backstop can be angled. So if your part, say like this was just a box, then you don't even need this breakaway. You can just use the edge. But since this is round, I've seen some of the suspension brackets. You can add this piece of material on, as long as the laser doesn't break it away while the part is in transit. Then you can just use this setup backstop on a brake press or the machine we have in the shop. Put it against it, bend it, and then you have another one on the other side to do that. Okay, so that's basically sheet metal. We don't really do a lot of hems, but hems, let's see if I can add it here. They look like this. They you might see them on some sheet metal. They do this so that way you don't have contact with a sharp piece of metal at the edges. It's flush. You can make it more sandwiched. And there are other features here you can explore. But yeah, I like to sketch on flanges rather than making a sketch and then extruding it and converting it to sheet metal. Some people have different preferences, but this is how I did. Okay, I think I'm done talking for today, unless we have any questions. Does anyone have any questions? There's only 10 of us left. This is recorded, by the way, so I'll post the recording in the Google Drive. Sorry, we went a little bit over time. It was only going to be an hour and a half, but it's okay. Only an hour and 42 minutes, only 13 minutes over time.
Thanks, guys. That was super helpful.
Cool. Anyone else? Questions, comments? There's a lot more that we could go into, but this is just for beginners. Someone else joining back in? We're at questions now. All right, well, that's it. We'll see you guys later. Might stop by the shop if there's a slot.
There's no one here.
Oh, really? See, that list was full.
Yeah.
Okay. What time does it close again on Saturday? 7:30?
I think 7:30.
Okay.
Oh, right.
All right. What do you guys think next time maybe more of a, I say like, I don't know how to say, like, not really a kind of a tour of different equipment that's available, so you would know like what you can design your part to be made on. Because knowing like the basics, your part, you know, having the radius and stuff. If I were to like show you all the different equipment that we have on maybe some sort of virtual tour of mass precision, you would understand more of the capabilities available. So you can get ideas on how you would make your parts. I don't know if that would be helpful. Okay. See you guys later.
All right, see ya.